The more things change, the more they stay the same. As the political environment changes, as the workforce ages, as environmental demands heighten, as plant equipment racks up the hours, the Intermountain Generating Facility continues to set the pace as the undisputed frontrunner in the coal-fueled electric generation industry. For still another year, industry comparisons show IPP near the top in almost every category when compared to similar facilities in the American West. This brief report outlines a few of the challenges and the solutions that have kept IPP on top for another year. Intermountain has recovered from the Unit 1 generator connector ring attachment failure. Repairs and modifications have been made to both units to prevent this failure from reoccurring. General Electric recommended modification of the bolted interconnection between the existing generator stator connection ring and the generator bus. The modification included the addition of an extension cap to each stator connection ring tang. The extension provided the addition of a second row of bolted fasteners for the flex leads from the stator connection ring to the generator electrical bus. The bottom row of holes for the extension cap were aligned with the existing tang bolt holes, and the cap was brazed to the tang using an induction heated brazing process. The extension cap added length to the tang to allow the addition of the second set of bolt holes. To accommodate the extension of the connection ring tang, the generator bus connections were shortened. These modifications were done by GE. They did not require disassembly or removal from the stator. Concurrent with this modification, inspections and extensive resonance testing was conducted and analyzed on the generator stator. Installation of specialized VibroSystem fiber optic vibration and temperature probes were installed on the stator connection rings. Net unit heat rate for the generating station is at 9,775 BTU per kilowatt hour, a noticeable improvement from the last 2 years. Several factors contributed to this improvement, including the installation of the 3 replacement Toshiba LP rotors during the Unit 2 6-week major outage. The last stage buckets, which were originally installed in November of 2010, were transferred to the new rotors. The L1 pressure plates in LP turbine C were also replaced with new diaphragms. Also contributing to this net unit heat rate improvement is the improved condenser back pressure, achieved by improving water flow characteristics through both unit cooling towers and reducing leakage of the water distribution system. High-energy steam drain piping in the condenser hot well was replaced, along with 2 water box expansion joints. Circulating water pipe sections were repaired with carbon fiber wraps. Circ water line thrust support was improved, along with cooling tower mechanical renovations. In the cooling towers for both units, the lower PVC fill was removed and replaced. About 1/2 of the fiberglass flume plates, which were cracked or broken, were removed and replaced. Nozzles and strainer covers were added in the distribution flumes to expand water coverage over the lower fill, plus to reduce sediment loading in the flumes. New internal and external sliding doors were also replaced. The functionality of the interior doors have a large impact on performance whenever a cooling tower fan is taken out of service. During the Unit 2 outage, an inspection revealed that IP turbine bucket covers had lifted and become detached on the IP turbine inlet stage. The IP turbine outer and inner shells had to be removed, revealing that the bucket covers had angel-winged, lifted, and become detached on the turbine end of the 8th stage. The 9th and 10th stage bucket covers had also shown signs of solid particle erosion, SPE, which had eroded the underside and lifted the covers, but they hadn't become detached. The cause of the SPE is coming from the boiler reheat section due to long-term heat damage, which is an industry problem with older boilers. Bucket covers eroded from the steam flow side, pushing up or angel winging the outer portion of the cover. The cover then caught the spill strip of the diaphragm, which rolled out both the bucket covers and spill strips, and also caused downstream damage as failed components went through the turbine steam path. The IP turbine 8th stage buckets on both the turbine end and the generator end were replaced. The IP turbine 8th, 9th, and 10th stage bucket covers on both the turbine end and the generator end were also replaced. MATS, or Mercury and Air Toxic Standards regulations going into effect, will not allow the generating units to bypass the baghouse during startup after 2015. An oil lighter design which lowers opacity is needed so that smoke produced during startup will not foul the baghouse bags. 2 types of retractable lighters were installed and tested during the Unit 2 outage, and they have been in service since. Visual testing, as well as the continuous opacity monitor, verified strong smokeless flames with less than 5% opacity. Based on the best performance, highest reliability, and lowest installed cost, the B&W fossil power design was selected. The FPS lighters will be installed on the B&W lighters on Unit 1 during the spring outage in 2014 and on the Siemens ABT burners in spring of 2015. The project will also require the installation of igniter cooling blower skids and piping and ABB DCS revisions to include the additional flame rod detectors and cooling blower skids. Availability and equivalent availability are 89.9% and 89.3%, which compares to a 10-year average of 91.2% and 90.4%. Forced outage rate and equivalent forced outage rate are 1.58% and 2.11%. Net capacity factor is 75.4%, down as a result of low net output factor. The Intermountain Generating Station completed 2 years without a boiler tube failure on September 10, 2013. The boiler tube failure reduction program is reaping benefits, as Unit 1 has gone 1,084 calendar days, its second longest run in unit history, and the station is also in its second longest run in unit history, having gone 766 calendar days without a tube leak. EPRI's life management process and the AWARE software program contribute to the evaluation and resolving of trouble spots. The boiler tube failure quarterly newsletter keeps personnel aware of developments and improvements. Best practice guidelines, a cycle chemistry improvement program, and preemptive inspections help achieve these improvements. The Intermountain Generating Station's gross and net generation was 12,656 gigawatt-hours and 11,885 gigawatt-hours, as compared to a 10-year average of 14,226 and 13,391 gigawatt-hours. Coal burn was 5,187,000 tons, with coal heating value of 11,190 BTU per pound. The biggest impact on why these numbers are down 11% on net generation from the 10-year average is net output factor or dispatched load, which is 83.9% with a 10-year average of 93.1%, down 9.2%. The remaining difference is in station availability of 89.9%, with a 10-year average of 91.2%, down 1.3%. The shutdown event summary shows 16 total outages, with 2 planned outages, 5 unscheduled maintenance outages, and 9 forced outages. The Intermountain Generating Facility will continue to boldly lead the way into the future with confidence and courage based on experience gained in over a quarter century of unparalleled performance.